Good morning, everyone. I, I welcome you all for the projection of solids. Here is the problem which is displayed on the screen. The problem goes like this: a square prism, 35 mm sides of base and 60 mm axis length, rests on HP on one of its corners of the base such that the two base edges containing the corner on which it rests make equal inclination with HP. Draw the projections of the prism when axis of the prism is inclined to HP at 40 degree and VP at 30 degree. So I have to answer two questions: how it is resting and where it is resting. So the first question I answer, where it is resting, it will be resting on HP, and how it is resting. It is resting on one of its corners. It is resting on one of its corners of the base. So it is resting on one of the base corner. So I have to have a corner on my right hand side of the drawing. So I start drawing my square of 35 mm sides, which is the base side of it, and the axis length is 60 mm. So this is the diagram what I get. I'm going to draw a square in such a way that I have 35 mm of side of base. So this side, whatever I have, is of 35 mm. So this side, each side of a base of edge or a side, this side is of 35 mm. So I'm going to draw in such a way that I get my corner on my right hand side. So I'm drawing a square of 35 mm. I name it A1 in the bracket, B B1 in the bracket, C C1 in the bracket, D D1 in the bracket. When I see it from this end, I'm going to see it from this end. When I see it from this end, I can see point B, I can see point C as well as point A. So it is A dash here, then B dash here, and C dash here. Then I cannot see point D, so point D dash is in the bracket. On the similar note, whatever I have here, it is A1, and it is B1 dash, and it is C1 dash. All are there outside the bracket, and inside the bracket I have, that is the first one as D1 dash as well as D dash, whatever I have here. So here I have O dash, this will be O1 dash. So the same thing when I note down here, it is O and O1 within the bracket. Once I do it, I'm going to project it on the third diagram. I have an axis inclination, and my axis is of inclined at 40 degree to VP. I have an axis which is inclined at 40 degree to VP. That is, draw the projection of a prism. One, the axis of the prism is inclined to HP at 40 degree. So I have an axis inclination which is 40 degrees. So I'm going to draw an axis in such a way that I convert my axis inclination to the base inclination. So this is my 40 degree. This 40 degree and this is 90 degree. 90 minus 40 will be nothing but 50 degree. So this inclination, whatever we get, it is 50 degree. 90 minus 40 is 50. So this 50 degree, whatever I get, I'm going to draw a line, 50 degree line. Then I'm going to measure the distance here, that is from C1 to B1 dash, C1 to B1 dash, as well as C1 to A1 dash. So from here C1 to A1 dash. Then I'm going to draw a 90 degree line. Then the length of this will be nothing but 60 mm, because the length of the axis, whatever they have given, is 60 mm. So the length of this rectangle is 60 mm here, and this is the length what we are getting it in our front view. After that, what we are going to do is I'm going to project it from the top. I'm going to see it from the top. I'm going to see it from the top. So I'm going to project it downwards. I'm projecting all A, B dash, C dash, D dash, then as well as A1, B1, C1, as well as D1. From the top view, I'm just projecting it A from here, B from here, then I have C from here as well as D. These two projections, whatever I have here, that is, I'm getting from A1 from this end and A1 from this end, it is meeting at a point. I call it as A1, B1 from this end and B1 from this end, I call it as B1, C1 from this end and C1 from this end, so it is C1 and D1. From here D1 and D1. On the same note, I get my top view. It is A, B, C, and D. Then I have to understand the thicker lines and the hidden lines. To begin with, I'll finish the outside part of this solid. So I'm seeing it from the top. So I can see this whole top face. The whole top face is nothing but from A dash to B dash to C dash to D dash, as well as D dash to back to A. So it is A to B, B to C, C to D, and D to A. This whole top base is visible. So I draw this with the solid line. Along with that, I can see AA1, which is visible when I'm seeing it from the top. So I draw AA1 line. Then I have to complete the outside figure. So it is A1 to D1 and D1 to D, as well as A1 to B1 and B1 to B. So I have drawn this from A1 to B1, B1 to B, as well as B to C, C to D, D to D1, and D1 back to A. This is my outside part, which will always be a thicker one. And this line already I have drawn because it is visible from the top. This part is visible, this line is visible, so which I have already drawn, as well as from A to A1, which I have already drawn, that is A to A1. Only thing I have not drawn is from this point, that is I have not drawn C1 to D1, B1 to C1, and C1 to C. So that is the line which is coming out from this point. That is, from this point, whatever I get, it is C1 dash to C. It is nothing but C1 to C when I see it in the top view. So it is C1 to C. When I am seeing it in the top view, it is C1 to C, which will be dotted. But here I have already drawn A to A1. So my dotted line is merging with the solid line here. So it will not be a dotted in this portion, but in this portion it will be a dotted. Along with that, line going out from this point is nothing but C1 to D1, as well as C1 to B1. So it is C1 to D1 and C1 to B1. So C1 to D1 and C1 to B1 is dotted line. So with this, we have completed diagram number 1. It is a top view where it is resting. It is resting on HP with one of its corner. So I have projected it on top. The same has been increased with the axis length of 60 mm, and it is making an inclination, axis inclination of 40 degree with respect to HP. So I have converted the axis inclination to base inclination. Then I have drawn this rectangle, knowing the dimensions in the case. Then I have a axis inclination here. In this case, this point is nothing but for me O, and this point is nothing but O1. Now, this axis, whatever I have got, is making an angle of 30 degree to VP. So it is making an angle of 30 degree here to VP. But when I again go back, read the question, I don't have any appears to be word in the question. So I don't have appears to be in the question. So now what I have to do, I have to check whether the axis in the first diagram, second diagram, as well as in the fourth diagram, whether it is changing. So the axis in this diagram, this is the second diagram, what we have drawn in the front view. The axis length here, it is 60 mm, and the axis in this case, the axis in this case, it is 45 mm. Axis in this case, it is 45 mm. That means the axis in the second diagram and the axis in the fourth diagram, it is changing, and I don't have any appears to be word in the question. That means it is a locus problem. So now what I do, I just draw a line of 30 degrees to VP. I draw a line of 30 degrees to VP. I draw a line to 30 degrees to VP. I'm going to draw a line of 30 degrees to VP. Then I'm going to measure the 60 mm randomly here on this axis length, because my axis is making an angle of 60 degrees, 30 degrees. This is my original length of 60 mm. So I'm drawing it here. This is the length of my axis. It is 60 mm. Length of my axis is 60 mm. Along with that, I can just then I draw the locus of this axis. I draw the locus of this axis. This point is O1. This point is O1, and this point is O. I'm going to just tilt this along this length from here to here. I'm just going to tilt this whole thing here, for which I'm going to place a rectangle, that is a rectangle starting from D, D1, B, B, B1 and B. This rectangle I'm going to place it here, or else you can place this rectangle which is 1, 2, 3 and 4. Whichever you feel easy, you can place it. But since this is very easy problem for a square, we can place this axis triangle rectangle, or else I can place this 1, 2, 3, 4 rectangle here on this axis. So for which now, as of now, I'll just be placing this D, D1, B1 and B here on this line. So now for which this is my locus, for which I have a locus. This is my locus of O, and I know in the fourth diagram the length of the axis is 45 mm. So from here I'm going to just measure in such a way that the length of this is 45 mm. I'm just going to extend this. I'm just going to extend this line in such a way that this point is O1 and this point is my new point O. Now for this line, I'm going to draw a 90-degree line. I'm going to draw a new 90-degree line. For which I'm going to draw a new 90-degree line here. On the similar note, on point O1, I'm going to draw a new 90-degree line. Okay, then I'm going to measure from O1. I'm going to measure point B. From O1, I'm going to measure point B. What is the distance from O1 to B1? From O1 to B1, it is 25 mm. From O1 to B1, it is 25 mm. The same will be in this case, it will be 25 mm. The same will be this in this case 25 mm as well as in this case. So at a very instance, I can find out point D, D1, B1 and B on these lines. So from O1 it is 25 mm here, 25 mm here on this side and 25 mm on the other side. On the same note, I have from point O, from point O, I have 25 mm here and 25 mm on the other side. So with this, I just join those lines and I name them. I name those lines. It is nothing but this point is nothing but it is T1. This point is nothing but B1. This point is B and this point is D. Now I have got D1, B1, B and D. Now I come back. I have got from this figure, I have got D, D1, B1 and B. Now I have to have another 4 points, which is nothing but A1, C1, A and C. And see that all the lines, all 4 points, that is the corner A1, C1, A and C are on the same line. So for which I am going to measure from A1 to O1. If I measure it is 1.4. The same will be the case here, it will be 1.4. The same will be the case here, it will be 1.4 as well as here it will be 1.4. So what I do from O1, I'm going to measure the length in here. From O1, I'm going to measure the length. From O1, I'm going to measure it is 1.4. And the same thing here, I'm going to get it. And on the same note, I'm going to find out 1.4, which I have got. It's not necessary. I'm just using this a small scale, you do it with exactly what you get. Or we will just check it again. It is 1.4. Yes, it is 1.4. The same will be the case with everyone. So I have got the points. That is, this is the point which is nothing but A1. This is the point which is nothing but C1. This is the point which I get as A, and this is the point which I get as C. Once I get all the points, I'm just going to draw the lines from A1 to B, B to C, C to D, and D to back to A. D to back to A. Similarly, I have from C1 to B1, I have a dotted line. So it will be a dotted line. C1 to D1, I have a dotted line. So it is a dotted line. Then I have a thick line from D1 to A1 and a thick line from D1 to B1. And also I have a dotted line here, which should be a dotted line. So this is my dotted line. So with this, I have drawn a locus problem. I have taken up bit time to solve it, but we have drawn the locus problem to solve this axis inclination, where I have axis inclination from the problem where we don't have appears to be words in the question. That means the axis in the 4 diagram is varying with the length with the axial length in the original length of 60 mm. So what we did, we have taken up the original length, which is from this diagram. It is nothing but 60 mm. This 60 mm, I have placed it. I have drawn a 30-degree line here in the beginning. Then from O1, I have placed a 60 mm length from O1 to O. With this length, I have drawn a line which is parallel to my XY line, and I name this line as a locus of O. Then in the fourth diagram, I have taken up the length of OO1. The length of this OO1 is 45 mm. I have kept O as a center, and I have cut it down this locus at some point of length of 45 mm. Then I have extended this line, the whole line. Then I have drawn a 45-degree line here. This is at point O1 as well as at point O. I have drawn a 45-degree line. Then I have placed this rectangle, that is point D, D1, B1 and B. You can do with 1, 2, 3 and 4. Even you can place this rectangle over there. But these points, if you're placing 1, 2, 3 and 4, you have to make sure you're drawing a rectangle here like this with these points, so that you have already from O1 you have to, or first you have to measure this A1, and from O you have to measure C. Then here you have to draw a 90-degree line. Instead of at this point, you have to draw it at this point here, so that these two lines are parallel. So you cannot place 1, 2, 3 and 4 at point O1 and O. It, this 1, 2, 3 and 4 are at point A1 and C. So even if you want to place 1, 2, 3 and 4 rectangle, in that case you have to measure from O1 to A and O to C, then draw a 90-degree line here. Okay, then you can get all the points, other points. Now I, instead of doing all that circus, what I did was I know D, D1, B1 and B. Since I knew it, I have drawn a 90-degree line. Then I have measured from O to D, O to B. I have cut this line here. Then on the same similar note, I have point O1 to D1. I have measured it. I have cut it down from O1 to B1. I have measured it. I have cut it down. I have got D1, B1, B, and D. Then when I see the diagram, A1, C1, A, and C are all on the same line. So from O1 I measure A1, from O1 I measure C1, from O1 I measure A, and O1, O2, C. Once I get all the points, whatever is there in this diagram, I'm just replicating it here by joining the edges from A to B, B to C, C to D, D to A. On the similar note, I am joining A1 to B1, A1 to D1, and D to D1 is, and B to B1. I have already joined it. Now the remaining left is C1 to B1, C1 to D1, which will be a hidden line, that is a dotted line, as well as A to C. This point will be a dotted because C1 is a hidden line, but this A to C1 is merging, the dot lines are merging with the solid line of A1. Next is what I'm going to just project it upwards and then sideways. So I have point A here. I am going to just project this face first. So I have a projection of B and C first. Then I have a projection of A. I have a projection of A here. So this is my projection of A point A1, which I'm taking it at this point, and this is the projection of A1. So I name this point as A1. Then this point is B1. The projection of this point is B1. Projection of this point, it is on the axis line, the XY line. So I'm just projecting it till this XY line because C1 is a point which is coming from here and C1 is a point which is coming from here. On the same note, I have D1, I have D1 which I'm projecting it upwards. So I have got all the points. This is my A1, this is my B1, this is my C1, and this is my D1. Okay. That is again, I'm going to do it with a dash. That is A1 dash, B1 dash, C1 dash, and D1 dash. Then I have the lines of the top base, which I need to project it on top. So I have a point A, which is at the top. So this is my point A. Then I have point B. Then I have point C. Then point D. The same I'm going to project it from the sideways. This is C. This is B and D. And this is point A. Once I know all, so this point is A dash. This point I get it as B dash. This point is C dash. And this is the point with D dash. I join all the lines from A dash to B dash, B dash to C dash, C dash to D dash, then back to A dash. Similarly, from A1 dash to B1 dash, D1 dash to C1 dash. C1 dash is here. Then from C1 dash to D1 dash, D1 dash to back to A dash. Okay. Then join CC1. It is CC1, then AA1, then I have BB1, then I have DD1. Okay, I've joined all the bottom base, top base, as well as all the longer edges from the top to the bottom. Now, only thing I have to check out is my hidden lines. Is my hidden lines, which I need to make sure. So the first thing what I'm going to do is I'm going to understand which is the farthest point here, which is the farthest point here in the fifth diagram, which is the farthest point in the fifth diagram. So the farthest point in the fifth diagram, which is the farthest point in this diagram, the farthest corner, it is nothing but not this. These corners are not the farthest. Out of these four, which is the farthest, nor A, nor B1, nor C1, the farthest is D1. So the line going out from D1 will be hidden lines. So the line going out from D1 will be a hidden line. So this is the line going out from point, that is the corner, which is D1. So the line going out from this point will be hidden lines. So I have a dotted line here, that is from D1 to A1 I have a dotted line. Then from D1 to C I have a dotted line. Then from D1 to D I have a dotted line. Dotted line concept is what? I'm drawing, I'm seeing it from here, the farthest point, that is the farthest corner. I'm going to identify the farthest corner. For me, the farthest corner is nothing but D1. So from D1, what all points, lines, that is the edges which move out from D1 will be dotted. So the line going out from D1 is D1 to A1, D1 to C1, as well as D1 to D. So these are the three lines going out from the point, that is the corner D1. So D1 to A1 will be dotted, D1 to C1 will be dotted, and D1 to D will be dotted. Is this problem clear, everyone?